So what we want to look at in this video is we want to actually talk about the difference between mass and weight. So when we're just going to start off and put a definition up for mass. And so mass is essentially the quantity of matter that you have. And basically this quantity of matter is like that stuff you have. And basically it's also a measure of the inertia. Inertia or sluggishness. Or you can think of it as the resistance to changes in motion. So, when we have mass, we're just going to use it as this definition. Now, the interesting thing about mass is there's actually a difference between mass and weight, because mass is the fundamental. Weight is essentially mass times the gravity that you're in. So the idea is that your weight varies. Your weight can change. The mass does not. So mass is a fundamental. Weight changes. Weight varies. So as a simple example to think about the difference between mass and weight, mass, let's say you have mass, you have a rock, and its mass is 60 kilograms. On the Earth, this rock would weigh 60 times 10, which is 600, and we measure weight in newtons. Now on the moon, this same rock is 60 kilograms, but the moon has gravity that's 1/6 of the Earth's. So it would be 6 over 10, or on the moon, this rock would weigh 100 newtons. And so what we see is that on the moon, the rock weighs less than on the Earth, but its mass is the same. So when you have to go to move the object, it still resists motion the same way, whether it's on the Earth or the moon. It's just the weight, its influence by gravity is different. The support force that's pushing up on it is different. But it still has the same mass. It would still be difficult to move in either location because of the fact that it's 60 kilograms. The mass is its sluggishness, its resistance to changes, not its weight. So mass is different than weight. Now another interesting thing that we usually think about when we're thinking about mass and weight, we usually sometimes associate accidentally the volume reduction. You think, oh, that object is really big, therefore it must be really heavy or have a lot of mass. But in reality, mass and volume aren't the same either, right? Because when you're thinking about, you can think of another simple example for volume. If I have like a beach ball, so I have a beach ball, let's say your beach ball has a certain size, or I have a rock of the same size as your beach ball. Which one is easier to move? The beach ball or the rock? Well, of course the beach ball is, because just because something is big doesn't necessarily mean it has a lot of mass. So there's no necessarily correlation, so we don't want to have a correlation between volume, the size of an object, and its mass either. So mass is just a quantity of matter, and it's a measure of its inertia. Weight is the mass times the gravity. So mass is the fundamental, weight is the one that changes, and also there's no correlation between volume and mass necessarily. Just because something's big doesn't mean it's massive. Okay. Now the last thing we need just to mention is there's in terms of mass, it just so happens on the Earth that we have that 2.2 pounds is 1 kilogram. But pounds, these are a measure of weight. Pounds are not mass. This is not mass. So we do not want to confuse weight and mass. The kilogram is the fundamental. If you want to use the British standard or US standard, the imperial unit, it's actually the slug. And the slug and the pound are, you need to take your slugs and multiply it by gravity to get a weight in pounds. But the pound is not a measure of mass, it's a measure of weight. So don't confuse pounds with kilogram. It just so happens on the surface of the Earth that 2.2 pounds is a kilogram, but that equivalency only holds here on the Earth. So just to recap, mass is the quantity of matter that you have. It's a measure of the inertia or sluggishness. It resists change in motion. Weight is not the fundamental. Weight is actually the mass times gravity that you're in. So your weight changes, your mass does not. And just as also a note, remember that 2.2 pounds is 1 kilogram. Even though you're comparing weight to mass, this only holds on the surface of the Earth. It doesn't hold elsewhere. And remember that just because something has a large volume doesn't mean it's actually massive. A large volume could just mean that it's just a big, light object.